welcome to the video for lesson 3-2 for the Math 050 class. We are doing this on March 31st. You've hopefully done the prep skills. So prep skills mostly talking about equations, slope and y-intercept, which we studied in 3-1, combining like terms. Lesson 3-2 is entitled A Snow Job. You'll see why later. Really, we're talking about using expressions and equations in the context of a story. You'll kind of see that from the objectives. That's what they're talking about. Context means what does the math mean in terms of the story. Okay? So after you read that, go ahead and answer question 1 in the classwork and pause the video while you do that. When you are done, restart the video and I will discuss the question with you. But I want you to think about it first. So pause the video and then restart when you're ready. Okay, when a company is making money, which is the goal, profit will be positive. What is the relationship between revenue and cost when this happens? Um, Revenue is how much you make, cost is how much you spend. If you have a profit, that means the revenue is greater than the cost. If you don't remember the greater than or less than symbol, that's okay. We'll need that later, but for now, you could just say greater than. So go on to question 2. Pause the video and answer question 2. We'll discuss it when you come back. Question number 2, that we're given a spreadsheet now that has a lot of different information about a business, a snow cone business. That's where the title of the lesson comes from. So 300 snow cones are sold. How many ounces of syrup are needed? What if 500 snow cones are sold? We're really just starting to look at how to use the table here. So we have 300 snow cones here, and the amount of syrup here is 600. 500 snow cones, the amount of syrup is 1,000 ounces. So just have 600, 1,000, and you should write ounces. Okay. Go on to question 3, and we'll see you when you return. Okay. Question 3 says a formula was typed into cell D5 to obtain the result you used to answer question 2. What formula would give the correct result? So we're looking at D5 here, which is what we looked at before. And really, D5 is going to equal. So I'm going to write it mathematically. D5 equals A5 times 2. So we'll say 2A5. If you're actually interested in doing it with an Excel formula, you do not write the D5 in the Excel formula. You simply write the formula into the cell D5. So you would type equals 2. Asterisk is used for the multiplication in Excel, as it is in a lot of computer applications. Okay. So question 3, we're just going to multiply whatever's in column A times 2. Pause the video and try question 4. Okay. Let me find question 4 here. Write a verbal description of the relationship between the number of snow cones sold and the number of ounces of syrup. I'm not going to take the time to write it, but you should say something along the lines of the number of ounces of syrup needed is twice the number of snow cones, or you need 2 ounces of syrup for every snow cone sold. Restart the video when you're done with question 5. Okay, if X represents the number of snow cones, then blank represents the number of ounces of syrup used. They're just asking for an expression. We have decided we're going to multiply the number of snow cones by 2. And when we're using X to represent the number of snow cones, we want to say that we're going to multiply 2 times X. That's what we mean when we write 2X. So 2X represents the number of ounces of syrup used. And you'll notice here they mention once you write an expression, a lot of times you use that expression then to write an equation. Okay. I suspect that's probably what we're going to do in question 6. Restart the video when you've answered question 6. Question 6, using the letter S to represent the amount of syrup used, write a formula that describes the ounces of syrup needed in terms of the number of snow cones sold. So we're still considering the number of snow cones to be X. And we've decided we're going to calculate S by doing 2X. So we can write an equation and say S equals 2X. S is the number of snow cones, or is the number of ounces of syrup used, and that is going to equal 2 times the number of snow cones sold. Pause the video and try question 3. Come back when you're done. I'm sorry, I said question 3. I meant do the did you get it. So check the did you get it. If you didn't get it, try to figure out why. If not, email me and ask me a question. Perhaps you might want to discuss it in a WebEx session. Remember, I will do those if you ask. If you think that would be helpful, we will set those up. If not, we'll continue just doing the videos. So assuming everybody did you get it, now try question 7. Question 7, does the number of snow cones sold depend on the amount of syrup used, or does the amount of syrup used depend on the number of snow cones sold? In answer to that question, I'm going to think about this. If the snow cones sold depends on the amount of syrup used, I could open the syrup, pour the syrup out, and I would automatically sell snow cones. That won't happen. Increasing the amount of syrup used will not increase the amount of snow cones sold. So the syrup depends on the number of snow cones. So, pause the video, and when you've answered question 8, come back and we'll discuss it. Question 8, in your formula for question 6, which is the independent variable, the input, and which is the dependent variable? That's based on our answer to question 7. The independent variable we decided was the number of snow cones sold. So we look at the number of snow cones sold does not depend on the amount of syrup used. The syrup depends on the amount of snow cones sold. So the syrup is the dependent, and the snow cones is the independent. Restart the video when you've answered question 9. Okay, is the relationship between the amount of snow cones, the amount of syrup used, and the number of snow cones sold linear, exponential, or neither? Explain. The easiest way to think about this is to go back to the table and look at the table that was done, you'll notice the number of snow cones goes up by 100 each time. 100, 200, 300, 400, 500. So the syrup is going up by a constant amount. I'm sorry, the snow cones go up by a constant amount in the table. And you'll notice that the syrup goes up by a constant amount too, 200 every time. 200, 400, 600, 800, 1,000. So it's a linear relationship. Um, so it's linear because it goes up by the y value goes up by a constant amount as the x value goes up by a constant amount. I say y value because we're used to thinking of it that way. It's actually, in this case, the s value, but it works like we are used to using the y value. When you answer question 10, restart the video and we will discuss it. Question 10, if X represents the number of snow cones sold, what quantity described in the spreadsheet would be represented by 5X? So we're going to say something equals 5X. So we have to go back to the spreadsheet, which is right here. We go back to the spreadsheet. What is 5 times the number of snow cones sold? And looking through this, cups is the same, syrup is times 2, cost of syrup. Ice is 500, so 100 snow cones, 500 ounces of ice. 300 snow cones, 1,500 ounces of ice. So ice is 5 times the number of snow cones sold. So we can say ice is equal to 5 times X. If, I'm sorry, restart the video when you've answered question 11. So question 11, if 70 snow cones are sold, the value of 5X is 5 times 70, which equals 350. Write a sentence or two explaining exactly what that what that result tells us about the snow cone business. Looking at the table, we saw that 5 times the number of snow cones was the ice. So we can say if you sell 70 snow cones, you will use 350 ounces of ice. Restart the video after you answer question 12. So question 12, if you were to graph the data in columns A and J from the spreadsheet with number of snow cones on the horizontal axis and total cost on the vertical axis, would the graph be a straight line? How can you tell? So the answer is, again, yes. For the same argument that we said syrup was linear, we go up by a constant amount every time. That tells us we're going to have a line. Restart the video once you've done question 13. Okay, question 13. Now plot the points corresponding to columns A and J. Do they form a straight line? What is the y-intercept? Okay, so A and J. J is the total cost. A is the snow cones sold. Okay. So we'll look at J. 245, 257, 269, 281. So we're going 0. 245 is 0. 245 is just a little bit below 250. 100 was 257. So just a little bit above 250. 200 was 269. So 200, 269. If I go from 250 to 300, halfway in between is going to be 275. 269 is going to be slightly below 275, so I'll put my dot there. Um, 281 is 300. So at 300, I'm at 281, which is just a little bit above halfway between 250 and 350. And 293 is going to be almost 300. So when I get to 400, I'm going to be almost 300. I come back and 500, the total cost will be 305, which is a little bit above 300. So I am not going to try to draw a straight line here. I think I can get the computer to draw a straight line. Eh, let's just draw the straight line. Anyway, that's as close as I can get, but you can see from the points that it is a straight line. Restart the video when you've answered question 14. So, turn off the ruler. Write a unit rate that describes the combined costs of all supplies needed per snow cone. So, combined cost of all supplies, I have to go back here and combined costs, sell 0 snow cones, cost me $0. Sell 100 snow cones, the supplies cost me $12. So unit rate, first of all, I need a rate. And I've got $12 per 100 snow cones. So I have a rate, and I've written it as cost or dollars per snow cone. But I need a unit rate. So I actually have to divide them both by 100. Because a unit rate, if you'll remember, I want 1 in the denominator. 100 divided by 100 is 1. 1200 divided by 100, I can just move the decimal place. And you'll notice 0.12. So actually 12 cents. If I divide $12 by 100, I get 12 cents. But we write it as $0.12. Restart the video when you've done question 15. Okay, pick 2 points from the graph. Remember, the points are coming from the table, which means they want you to actually get the numbers from the table, not from the bad graph that I drew. And find the slope of the line connecting them. What do you notice? Hopefully, you will see what's going on here. I'm going to pick 100 and 200. So slope of the line, you might remember y2 minus y1 divided by x2 minus x1. I remember change in y divided by change in x. But we are going to take y2 minus y1. So y2 for 400 snow cones was 293, I believe. Yes, 400, 293. So 293 minus, and for 100 snow cones, it was just a little bit above 50, but I don't remember. 57. 257. These are dollars divided by, and now I take my x2 minus my x1. X2 is 400, x1 is 100, so I have 400 minus 100. And if I do that subtraction, 257, I get 36. 293 minus 257 is $36. Try it on the calculator just to make sure. 400 minus 100 is 300. And if you do that on your calculator, 36 divided by 300, you will find that you get 0.12 dollars. And instead of doing it over one, I'm going to say per snow cone, just to do that in the context of the story. It is, whether you put the one or not, it's still a unit rate. I could have put 0.12 over one. Point is, unit rates and slopes, when you have a linear relationship, unit rates and slopes are the same thing. Okay. Let's see, there's some more classwork. Go on to question 16. When you're done, restart the video. Okay. If each cup costs $0.01, write an expression for the total cost in dollars of the cups based on X. Okay. So now we're actually given a unit rate, and we see that from the word each. Each cup costs $0.01 or 1 cent. We want to multiply that by the number of cups, and we're using X to represent the number of cups. So when we write our expression, 0.01 X. Okay. Restart the video when you've done question 17. Okay, if 0.04 is spent on syrup for each snow cone sold, write an expression for the total cost in dollars of the syrup based on X. Same thing. They've worded it a little bit differently, but they're still giving us a unit rate. We're just going to multiply that unit rate times the number of snow cones sold. Restart the video when you've done question 18. You probably have figured out what's going on here. Write an expression. If the cost of the ice is $0.07 dollars, you multiply 0.07 times X. We'll see if 19 is a little more interesting. Okay. Total combined costs for making one snow cone looks like this. Write an algebraic expression for this, and then simplify your expression. So cost of cups plus cost of syrup plus cost of ice. So we're thinking of the total cost of supplies. Cost of cups was 0.01. And if we're going to add the cost of syrup, 0.04, and then we add the cost of the ice, 0.07. This is an algebraic expression. Sorry, actually, this is a numeric expression. So yeah, it's a numeric expression. Simplify it, you add them all together, you get 0.12, which you'll notice was the cost for one snow cone, the total cost for one snow cone. Okay. That will have something to do with question 12. After you've answered, I'm sorry, question 20. After you've answered question 20, restart the video. Total cost of selling snow cones is the sum of the variable cost for supplies, which we just found, and the fixed costs. These are costs that aren't affected by the number of snow cones sold. So rent, insurance, licensing, etc. look back at the table to find the fixed cost for this business, and then use it to write an equation of the form C equal that represents the total cost based on X, the number of snow cones sold. So let's look back. We talked about it earlier. You'll notice the cost for 0 snow cones is 245. That was actually the y-intercept of our graph. So if we do the total cost of snow cones, first of all, we have to take our 0.12 and multiply that by x. I think the author was actually intending for you to do 0.01 x plus 0.04 x plus 0.07 x equals 0.12 x up here. It's not what he asked for, but that's actually where this expression comes from. That will actually give us the cost of the supplies, but it doesn't tell us the total cost. We have to add that to the 245. And that will give us the total cost. So that's actually how we write an equation. And you'll notice that's the equation for the line because we have our y-intercept and we have the slope of our line. Let me see here. I think we are at another did you get it? So do the did you get it? If you don't get it, ask a question, see if you can figure it out. Then we will go on to the group work. So in our group work, next we'll study the profit made by the business. So we've got our equation. We're using that same equation. We're still using the same data, but now we're talking about profit. So question 1, find the y-intercept of the graph and explain what it means. So we've got a new graph now. They've given us a new graph. And you'll notice now our y-intercept is where when we sell 0 snow cones, how much do we make? That's actually 0, -4. So 0, comma, I don't know why I said -4, -245. What does it mean? It means when we sell absolutely 0 snow cones, our cost is our profit, more importantly, is -245. Because we have 0 revenue, we subtract our cost. We get -245. Question 2. When you've answered that, come back and we will discuss it. Question 2 asks about the x-intercept. That's where y is 0. We have this point over here. It's almost 400. And you'll notice from the data given 389, 0. So find the x-intercept. And you notice the x goes first. Y is 0. X is 389. Okay. Explain what it means. If y is 0, that means the profit is 0. And in terms of our story, in terms of any business, a profit of 0, so your profit is 0, your loss is 0, what we call break even. So this is the break even point. Or if you say point where profit equals 0 or revenue equals cost, that's what break even really means. Revenue equals cost, which means that profit equals 0. You start the video when you've answered question 3. Question 3, find the slope of the line. Explain what it means. So slope of the line we go back, take 2 points. So y2, 700, divided by x2, I'm sorry, 70, not 700. 70 divided by x2 is 500. And I'm going to subtract y1 and x1. So I'll go back here again to the origin. It doesn't matter. You should get the same result no matter which points you pick. Hopefully you pick different ones. If not, you might try it. So my y2 is negative 245. And I put the parentheses around so you can see there are two. We subtract a negative. Okay? 500 minus 0. Yeah. So if I evaluate that, subtracting a negative is like adding a positive. So my change in y is really going to go all the way along here. This is my change in y. So I have to take the 70 and I have to add the negative value. So to get that total distance, I have to add the two numbers. That's why subtracting a negative is like adding a positive. So I end up with 315, I hope. 315 divided by 500. All right. Slope of the line, 315 by 500. So in terms of what that means, we've got, let me put make sure, 70, so my y is actually in dollars. So my profit increases by 315 when I sell 500 snow cones. And if I do that division, I'm going to say, you don't have to do this, you could do this on a calculator. I'm going to multiply it by, I'm going to multiply them both by 2. So I get 630 divided by 1,000. Now I can do that in my head, because I just moved the decimal place 3 places. 0.63. And if I look at the slope of the line, what does it mean? For every snow cone, the profit goes up by 63 cents. Okay. We look at the terms of the other equation that we did. The slope of the line was 0.212. That was the cost. This is the profit. So for every snow cone they sell, they make 63 cents in profit. Okay. Restart the video once you've answered question 4. So question 4, we have actually found the unit rate for profit. Estimate the net profit of if 150 snow cones are sold. What is the significance of the sign? Okay. So we've got the profit for 150 snow cones. Not sure if they want you to do this graphically or calculate with a calculation. I'm going to do the calculation first. So we have 0.63 $63 times 150. Right. And then we are going to have our cost. We're going to have to subtract our costs, which would be our total cost would be negative 245. And if you'll remember, that's actually our y-intercept. So we take our 0.63 times 150. 0.63 times 100 would be 63. Times 50 would be half of that. So 63 divided by 2 is 31.5. So 63 plus 31.5 is 94.5 minus 245. So our net profit then would be 145 plus 5.5. But our 245 is bigger than our 94.5. So we actually have negative. And that's important because what's the significance of the sign? We are losing money instead of making money. Profit is negative. Restart the video when you've answered question 5. Question 5, estimate the number of snow cones that need to be sold to make a profit of $50. So first of all, question 4, I was going to go back and look at the graph. So 150 snow cones that actually ended up having a profit. 150. Our profit's about negative 150. And if we come back here, negative 150.5, that's pretty good. Profit, number of snow cones sold to make a profit of $50. We go back, if we're $70, we were at 500. To make $50 profit, we're a little bit more than 450, but we can actually calculate that. So estimate the number of snow cones needed to be sold to make a profit of $50. So we can actually say 50. Our profit equals negative 245 plus 0.63x. And what I'm going to do is add 245 to both sides. Which tells me that 293 equals 0.63x. And in the context of the story, we're going to need to accomplish what's asked for in question 5. We need to make $50 profit. We also need to make another $245 to cover our costs. So we need to make a total of $293. And to do that, we're going to divide, and I'm going to break down and get my calculator out now. Right. 293 divided by 0.63. We need to know how many 0.63s we need to get 295. So I'm actually going to divide 295 by 0.63, and I get 468.5. 0.25, but you can't sell a quarter of a snow cone. So once I do that division, I end up with x equals 468. Which, as I said, was a little bit more than 450. Restart the video when you've done question 6. So fill in the blanks. The profit starts at when snow cones are sold. Profit starts at negative 245. We open the business. We've lost $245 just getting the business going, and goes up by, for each sale, tells us we're looking for a unit rate, $0.63 per snow cone. So restart the video once you've done question 7 now. Question 7, you'll notice the book kind of walks you through things, and it wants us now to write an equation for profit. So profit, we know we're going to start at negative 245. That's what it costs us to get the business going. Okay. So to figure profit, to make a profit, we first have to get that $245. So we're going to subtract that from whatever we do. But when we sell snow cones, we add that. For every snow cone we add, for every snow cone we sell, we add 63 cents. So we multiplied 0.63 times the number of snow cones, and we add that to negative 245, or we subtract the 245. Let's see where we go from here. So now we're on to using technology. Don't worry about that because we're not allowed to use graphing calculators. Restart the video once you've answered question 8. Actually, we don't want to do that. So quick sketch of what your calculator screen looks like. I'm actually going to go to www.desmos.com. It's actually a good graphing calculator app. Oh, I mistyped it. 3 W's are enough. Okay, start graphing. And we have our equation. So we don't need to write the P. We'll just say negative 245 plus 0.63 x. And you'll notice nothing happened. Because everything was too small. But if we look at the graph now, we notice it starts at negative 245 and goes up to our x-intercept of 389. Started our y-intercept of 0 and negative 245. And at 500, we are at 70. Yeah, there we go. 500, we are actually at 70. So it looks exactly the same. The equation we put in gives us that same graph. So, if I can get, any rate, Go and try question 9. So we got that same spreadsheet. Restart the video once you've done question 9. Question 9, total cost from selling 400 snow cones. So once again, 400 total cost, 293. When you're done with question 10, restart the video. So question 10, revenue from 400 snow cones. So revenue is $300. We actually put $300 in the cash register. Question 11, try to answer that. No, don't necessarily write the Excel formulas, but just write a formula. Question 11, hopefully you wrote a formula. So go back J7 and K7. J7 is total cost. K7 is revenue. They want to find L, which is $7. And you probably figured out that came from, that $7 actually came from 300 minus 293, which was K7 minus K6 minus J6. Okay, so there, I was off a line. So actually, this is K6 minus J6. Anyway, let's do it right. So 375 minus 305 gives us 70. So yeah. So 375 was K. Yeah, so K7 minus J7. And I'm going to put the equals over here, L7. So we just take the K7 minus J7 to get the L7. Restart the video when you've answered question 12. Write a verbal explanation of the relationship between the profit made from selling a certain number of snow cones and the revenue and total cost from selling the total snow cones. So verbal explanation, profit. To get the profit, we are going to take the revenue and subtract the cost. Oops. So P equals revenue minus cost. You'll see that sometimes P equals income minus expense. Those words are basically the same thing. Cost and expense, expenses, revenue and income, same thing. So actually having it written it this way probably answered question 13 for you. But at any rate, try question 13. You'll notice that P equals I minus E. You can remember that because it spells pi. Restart the video once you've answered question 13. Okay. For question 13, we use P to represent profit, C to represent cost, R to represent revenue. They actually want you to write this equation that I just wrote. Let's try to do a shortcut. And I answered question 13 for you. Restart the video once you've answered question 14. Question 14. Question 20 of the class portion, you represented total cost with the expression 0.12x plus 245. Using the same line of reasoning, find an expression that describes the revenue from selling X snow cones. So revenue, so the cost was 0.12x was the cost of the snow cones. We have found that the revenue is actually a unit rate of 0.63. They give us a big clue there. We make 63 cents, or we sell snow cones for 63 cents. So let me double check that. So revenue, I'm sorry, we need to find a unit rate. So we look at 100 snow cones. We actually make $75 per 100 snow cones, which means our unit rate is $0.75 per snow cone. Now we can write an expression for revenue. So our expression for revenue is 0.75x, which means we are charging 75 cents for each snow cone. That's how we get $75 when we sell 100 snow cones. Okay. Going to do a little bit of interesting stuff in question 15. It kind of seems like it's kind of deviating, but we're going to use it later on in our understanding of the expressions. So try question 15. Restart the computer once you've done that. Okay. Is 5 minus the quantity 7 minus 3? You'll remember parentheses say do the 7 minus 3 first. Is that equal to 5 minus 7 minus 3? Or 5 minus 7 plus 3? A lot of people like to think, well, I can just do the subtract the 7 and then subtract the 3. But actually, PEMDAS tells us to do the subtraction first, which is 5 minus 4. We have to do the 7 minus 3 first. 5 minus 4 equals 1. If I do the 5 minus 7 minus 3, PEMDAS says to do that in order. 5 minus 7 is negative 2. Negative 2 minus 3 is negative 5. So this one does not give us the same answer. So if we look at 5 minus 7 plus 3, we get 5 minus 7 is negative 2 plus 3. That gives us the same answer as doing the parentheses first. Okay. Question 16, you're going to use that idea. So make sure you understand that idea and then take a look at question 16. Okay. Question 16. Subtract the expression 0.12x plus 245. You'll notice that was our expression for cost. Our costs are 12 cents times the number of snow cones plus our upfront costs of 245. We want to subtract the expression from the one you wrote in question 14. Question 14 was where we talked about the revenue. So we have 0.75x, our revenue. We are subtracting our cost, 0.12x plus 245. Go on to question 17 and restart the video once you've answered question 17. Okay. Question 17, use your expression to find the profit made if a company sells 8,000 snow cones at a festival. So you'll notice this is revenue minus cost, the expression that we wrote in question 16. We decided that was equal to profit. So we can say our profit equals 0.75x minus 0.12x plus 245. Okay. And I am not sure if everything is here or not. I think the book also wants you to look at, compare that to question 15. In question 15, we found we could take P equals 0.75x and subtract 0.12x. But then we cannot add the 0.245. We have to subtract I'm sorry, cannot add the 245. We have to subtract the 245. We found out that if we have parentheses, if we're subtracting parentheses, we can either add them first and then subtract the two numbers together, or we can subtract them individually. So in the first case, I add my costs together, and then I subtract both costs at once from the revenue. In the second equation, I subtract my costs from the revenue, but I do them individually. So I subtract them both because they're both costs. I subtract each cost because costs are subtracted from revenue. In the first equation, I want to subtract them both, but I add them together first. Once I add them together, I subtract the entire cost. I subtract the cost all at once. Either way, I'm subtracting both costs. If I take the parentheses out, though, now I can combine that. I'm sorry, I misread question 16. Question 16 was actually asking us to do this. Now I can look at this and I can say, if I make 75 cents on each snow cone and I pay 12 cents, I can take 0.75 minus 0.12. That gives me 0.63x, and then I subtract 245. Question 16 was actually asking us to do that. Anyway, I've done it now. Question 17 actually wants us to find the profit for 8,000 snow cones. So P equals 0.63 times 8,000 minus 245. I can say P equals, and I'm going to go back to my calculator. Yep. And I'm going to say 0.63 times 8 thousand minus 245 equals $4,795. All right, looks like we have a did you get it coming up. So do the did you get it really quick, check your answers. And if you didn't get it, ask a question on the discussion board or send me an email. Okay. We go to our portfolio. Remember, the only thing you do in the portfolio is the applications. Um, Remember, there will be a place where you can upload the applications under assignments. So you go to the classroom in D2L. Um, I believe it's activities, assignments. There will be an assignment for 3-2. You can upload a picture of the applications to that area. Um, Send me an email. Let me know how things are going. Let me know if you have any questions, and I will see you for lesson 3-3.